So in lesson 59, we're going to talk about substitution again. Remember, we had some problems similar to this, except it might have said x equals 1 plus 2y, or y equals 2x plus y, or plus 1 or something. So today, what we're going to do is we're actually going to rearrange before we start substituting. Because you can see here, we don't know what our x value is and we don't know what our y value is. So we got to be able to find our x and y value first before we can substitute anything in. So in this case, you can see we have an x minus 2y equals -1 and 2x minus 3y equals 4. Does it really matter which one you go with and try to solve? No, it doesn't. But just to make things easier, as you can see here, we have an x minus 2y equals -1. If we simply add 2y to both sides, we'll have x equals something. So what we're going to do is we're going to cross this out. We're going to add 2y to both sides. And what we're going to end up with is x equals 2y minus 1. So now that we've got x equals 2y minus 1, what we're going to be able to do now is substitute in this x equals 2y minus 1 in down here for where x is and solve the problem. So we're going to go 2 times 2y minus 1 minus 3y equals 4. So all we simply did was, instead of where x is, we just replace it with 2y minus 1. So now we're going to do the distributive property here. 2 times 2 is 4y. 2 times -1 is -2 minus 3y equals 4. Now we have like terms before we can go any further. We have a 4y and a -3y. When we combine those, we get y minus 2 equals 4. Now we simply just add 2 to both sides, and we're going to come up with y equals 6. Now we're not done. Remember, in order to get a correct answer, we have to have an ordered pair. So we know what y equals now. All we have to do is simply find what x is. So what we're going to do is we're going to move y equals 6 in up here where x equals 2y minus 1. So we'll go x equals 2 times 6 minus 1. So all we simply did was replaced y with 6 here. And so we have 2 times 6 is 12 minus 1, and x equals 11. So our order pair is going to be 11, 6. So all we simply did was we rearranged first x minus 2y equals -1. We rearranged it to make x equals 2y minus 1. We substituted in for x and got 2y minus 1 down here. We did our distributive property and found y. Once we've done that, we simply just substitute in y for 6 and got 2 times 6 is 12 minus 1 is 11 and got an order pair of 11, 6. So let's take a look at another example. This time we have 2x minus y equals 10 and 4x minus 3y equals 16. So as you can see here, we have y by itself over here. So all we need to do is simply just subtract 2x from both sides. So if we subtract 2x, let's just write it down here. 2x minus y equals 10. We subtract 2x from both sides. We're going to leave it with -y equals 10 minus 2x. As you can see, we don't have y by itself. So what we have is we have a -y. So in order to get y by itself, we have to divide by -1. So everything on the other side is going to be divided by -1 as well. So these was with y equals 2x minus 10. So instead of this equation here, we're now going to have y equals 2x minus 10. So now what we can do is we can go through here now and we can substitute in where we have y, we can substitute in 2x minus 10. So we're going to have 4x minus 3 times 2x minus 10 equals 16. So all we simply did again was, instead of y, we substitute in 2x minus 10. So now we have 4x minus, we multiply 3 times 2 is 6x, -3 times -10 is 30, equals 16. When we combine like terms, 4x and a -6x gives us a -2x plus 30 equals 16. Now we can subtract 30 from both sides. We're going to get -2x equals -14. Now that we've done that, we divide both sides by -2, and we get x equals 7. So now we're not done, because we have remember, we have to find an ordered pair. So 7 is going to be our first number. We're going to substitute in 7 now for x up here. So y equals 2 times 7 minus 10. So then what we're going to do is we're going to multiply 2 times 7 and get 14 minus 10, and y equals 4. So again, we rearranged our first one and got y equals 2x minus 10. We substitute in for where y is and got 4x minus 3 times 2x minus 10 equals 16. We did our problem and we got x equals 7. Then we simply substitute in 7 for where x is in the other problem and got 14 minus 10 is 4, and our order pair is 7, 4. So let's try one more example here just to make sure we understand the information. So again, we have 4x minus 2y equals 38 and 2x plus y equals 25. Now again, it doesn't matter which one you choose, but just to make things easier, you see we have y by itself here. Y doesn't have a coefficient, so we can go ahead and just use y. We'll subtract 2x from both sides, and it leaves us with y equals 25 minus 2x. So what we can do is simply just erase what we have here, and we'll get y equals 25 minus 2x. So now that we've substituted, or we rearranged, now we can substitute in for where we have y up here. We can just substitute in the 25 minus 2x. So we'll get 4x minus 2 times 25 minus 2x equals 38. Now that we've done that, we'll go 4x, negative 2 times 25 is a negative 50, and negative 2 times a negative 2x is a plus 4x equals 38. Now we'll just combine like terms. 4x and 4x gives us 8x minus 50 equals 38. We'll add 50 to both sides. Leaves me with 8x equals 88. Divide both sides by 8. X equals 11. So remember, we have this in an ordered pair. Our first number is going to be 11. So now that we've got that, we just simply substitute in back in. We had y equals 25 minus 2 times 11. And then we can just multiply out 2 times 11. So we get 25 minus 22. 25 minus 22 is 3. So our final answer is 11,3. So again, we just simply rearranged our first problem, which was 2x plus y equals 25. We rearranged it to get y equals 25 minus 2x. We substitute in, well, we have y up here, we substitute in the 25 minus 2x, and to get 4x minus 2 times 25 minus 2x equals 38. We solved our problem and got x equals 11. And then we substitute in the 11 back up here where we had x, and got 25 minus 2 times 11, which was 22. 25 minus 22 is 3. So our final answer is 11,3.